What's up, nurslings? DrSqueech here, and today we're going to be talking about basic interpretation of ABG values. So when you look at a set of ABGs, of course, you have to know your normal ranges. Right now, we're just going to be focusing on the pH, the bicarb, and the CO2. So with your pH, the normal range is 7.35 to 7.45. Lower than 7.35 is acidic, greater than 7.45 is alkaline. With your CO2, your range is 35 to 45, and CO2 equates in the body to carbonic acid. Your bicarb is 22 to 26, and you equate bicarb in the body to base or alkaline. So the more CO2 you have, the more acidic you are. The more bicarb you have, the more alkaline you are, or on the basic side of the pH scale. So what we're going to do is we're going to interpret just uncompensated ABG values. And I'm going to show you a couple of different ways to do it. One of them is very well known, and another one I just kind of do because for me it's a little bit easier. So when we look at this one, the first thing you want to check is your pH. And all you want to do is you want to identify if each of these values is high, low, or normal. I just use the letter N and arrows up or down. So the pH, 7.29. This is below the normal level, so it is low. The next is CO2. 52 is above the normal range, so we're going to write an arrow going up. 23 is perfectly in the middle of the range for bicarb, so that is normal. With an uncompensated ABG value, two of the values are going to be abnormal, and one of them has to be the pH. So the first method I'm going to talk to you about is called ROME. Now, ROME has been around for a long time, and it stands for respiratory, opposite, metabolic, equal. And that pertains to the trending of the values. If it's a respiratory condition, the values that are abnormal are going to go in the opposite direction, one up, one down. And if it's a metabolic condition, both of the abnormal values are going to trend in the same direction. So the first thing you do is you look at the pH to determine whether you're in an acidic or alkaline condition. This pH is low, so we are in an acidosis sort of situation. But then we have to determine, is it respiratory acidosis or is it metabolic acidosis? If you use ROME, look and see what other value is abnormal. It's the CO2. And because the CO2 and the pH are in the opposite direction abnormally, it's a respiratory acidosis. So this would be an uncompensated respiratory acidosis. The other way you can look at these is look at the pH first. Is it acidosis or alkalosis? And what I do is I just look at the other abnormal value. If it's CO2, that's your lungs, that's respiratory. If it's bicarb, that's metabolic. That's just, to me, the quickest way. It's kind of the same thing as ROME, but you don't have to identify whether it's opposite or equal. It's just, is it the lungs or is it the bicarb? So this one is uncompensated respiratory acidosis. Let's do the next one. This one, pH is 7.48. It's above the normal range. So we're going to put an up arrow. A CO2 of 38, perfectly fine, perfectly normal. And a bicarb of 28. Now that's above the normal level. So now using ROME, we're in alkalosis because we have a pH that's too high, and it's metabolic because metabolic equal. Both of the abnormal values are trending in the same direction. If you use the other method, we're in alkalosis, pH is too high, it's bicarb, metabolic. This again is an uncompensated condition, but this one is metabolic alkalosis. You can do this with all four of the uncompensated conditions, and let me know if you have any questions or comments. Thanks.